In this video, I'll be doing a detailed solution to the maths question you see on the screen here from the Cambridge A-Level Mechanics paper 4.3 from 2024. If you're looking for a different question from this paper or a different paper entirely, check out the description below. And if you find this or any of the other videos on my channel useful and would like to help me out, the best thing you can do is share it with other people doing the exam. Perhaps if you're in a class WhatsApp group, share it there. Failing that, a like, subscribe, or even a super thanks. In question 3, they tell us a long story about a car travelling along a road. I'll skip through it a bit. They tell us there's 3 points on this road. Point A, B, and C. A, B, and C. The car, they tell us some information about the car at, let me draw a bad drawing of a car here. Actually, they tell us the acceleration of the car over all of time, so that's A. It's always accelerating at A speed. At the point A, it's going at this, accelerating, not, I said speed there. It's accelerating at an A acceleration. At point A, it's going at a speed U. Point B, I don't know. I guess, the way I'm going to do it, I'll find out. And at point C, I don't know its speed. Next they tell us the distance between A and B is, or more to the point, the distance between B and C is twice A and B. You don't have to do this, but I find it might just help put in an X and a 2X. So you get the distances there. And next thing they tell you how long it takes to go from A to B, and that's is it 8 and 10. Yeah, that's 8 seconds, and it takes 10 seconds to go between B and C. That's all the information you get. They want to find out what is U in terms of A. So just try and solve for U. Just try and find U, and if A is in your answer, that's okay. A and other numbers are all okay. You don't want to have something like what are we missing here? S, I guess. We're not going to find out any S's, or you don't want V from over here. So how do you do that? What you can do is play around with equations of motion. The one that's going to end up working out for you, do I have it there? No, but I guess I know ut plus a half at squared. I know this the other way around. This one's going to be really helpful for you, but I'm going to go ahead and pretend I don't know that, and I'm going to do it a little longer, but it'll hopefully help you see how I'm thinking about the question. And first of all, I rarely use these equations of motions that are in the book, the linear equation of motions, because you can find them on your own. And that's what I'm going to do. I'm going to get the motion of this car in general. What do I know about it? I know that A is equal A, the acceleration. Once you know acceleration, you can figure everything out nearly. We integrate. If you want to know V at all points of this car, we just integrate A. The integration of A is AT. And then we add on some initial speed. So what's the initial speed of this car? That's U. Okay. This is an equation, you know this though. This is U plus AT. So you're given this. I'm not inventing anything new here. This is just the way I think about it. S is just the integration of this. And it's actually just this equation. So that becomes t squared. A divided by this new number t. So A over 2, which is just half AT squared. And the integral of U is ut. Again, that's when I said I know this the other way around. This is how I think of it. And then plus some initial position. We'll say he's at the start of the world here. Okay? Now I'm going to do this question 3. I'll do it quite quickly. At A, his acceleration is A. His speed is t is 0. We're at 0 time here at A. This is the beginning of the world. So t is 0. So we have V is the U. Again, we knew this. S is t is 0. Put 0 in, we get 0. You know this. This isn't. I barely had to write it. I just want you to see how I'm thinking each time. At point B, this is much more interesting. A is still A. V, now we're 8 seconds into the world. V is 8 times A plus U. Oh, sorry, my A's and U's look alike. That's going to be a bit of trouble. I'll try and be much more careful. This is what we want, sort of, isn't it? We want the U with A's in it. Unfortunately, we don't want this V, so I'll stay going. This is the V at point A, V at point B. In a minute we'll get V at point C. Position at point A, 0. So the position after 8 seconds is 8 by 8, 64. 64 divided by 2 is 32A. So that's A. Plus 8U. Okay, that's 8 times U there. Now it's okay if you don't see where I'm going yet. Let me just do the last one here, C. We'll get all the information for C. Again, A is A. You don't have to write this, by the way. The velocity at C is equal to, what time are we at actually at C? What time do we get at C? 18, not 10. It's 18 seconds into the world. So we have 18A, 18 times A plus U. Maybe there's something we can do with these two V's, maybe. S though. S is 18 squared divided by 2. I'm going to have to go to my notes for that one, I'm afraid. That gives us 162A. And then 18 times U gives us 18 U's. Okay, this is all the information I know about these 3 points. If you want to pause the video at this point, try and solve what they asked you from here. They want U in terms of A, so they want U equals. So you have lots of options for U here. They want U equals, but the only thing in the answer can be A and numbers. So maybe this U, you have to get rid of VC. That's going to be difficult. Maybe this U, you have to get rid of VB. That's going to be difficult. This U, we'd have to get rid of this S. You can do that. This U, we'd have to get rid of this S. These are different S's though. Position at B, the position at C. This is the trick. Now you could have done this straight from the beginning. Just think of this equation here. So what position, do we know anything about this position? We don't really, but we do know in relation to the both of them. This X and 2X. Don't have to have 2X. What we know is the distance from this to this is twice the distance from this to this. Be careful there. This number is not twice as big as this number. Let me show you what I mean. This number was 0. If you take my number X here, this guy here, 32A plus 8U would be equal to X. That's his number there. This one though is 182A plus 18U is equal. It's not equal to 2X. It's equal to the distance from here. That's 3X. This equation is 3 times bigger than this equation. We have 2 equations, 3 unknowns. We can get one equation we can get rid of one equation down to 2, which is what we wanted. Hopefully that was clear. What I'm saying is multiply this top one by 3. We would get 96A plus 24U is equal to 3X. Well, they're equal to each other. That means these two are equal. And we have A and U together finally. So let's just start cleaning it up. These two are equal to, let me write it all again. 182A plus 18U must equal 96A plus 24U. They want U in terms of A. So let's get a U on its own. Move the 18 over here. We get 24 minus 18 is 6. 6U. What would be left on the other side? 162 minus 96. I think of it as minus 100. Get 62, except I took away 4 too much. So 66. Or use a calculator, of course. U must equal 11. Oh, sorry, I'm missing an A here, aren't I? These two A's should be an A here. U is equal to 11A. That's the answer to part A. Now, the good news of doing this a slightly longer way is part B is now much more trivial. Find the speed of the car at C in terms of A. There it is right here. The velocity of the car at C, the speed of the car at C is equal to 18a plus u. Except we know what u is. U is 11a's. So this is 18a plus 11a's, which is equal to 29a's. That's it. So that's the answer to part B. Just because I'd set all this out. It's often useful to do that in maths. Take the question, sometimes don't even try and answer what they said. Just take this situation and say, okay, what's everything I can know about this? And when it comes to motions and stuff like that, these three equations, that's everything you can know about each of those points. Didn't take that long, and now it's very easy to answer everything. I think of the same when I'm dealing with geometry, some shapes here. I look at the question they give me and I just find every angle and then look what they asked me, and I find it sometimes works out better doing that. Anyway, you don't have to take that advice. If you have any questions about this question or anything in general, I guess, let me know in the comments. I'll do my best to get back to you. Thanks for watching. Have a good day.